Hi guys, welcome back to my YouTube channel Code Ground, the battleground of coding. So today we are going to solve the daily challenge of October 5th, that is Pacific Atlantic water flow. So let's first read what the question is. Yeah, there is an end-to-end rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and the top edges, and the Atlantic Ocean touches the island's right and the bottom edges. Okay, so left and the top edges is covered by the Pacific Ocean, and the right and the bottom edges are covered by the Atlantic Ocean, and this is the island. Okay, the island is partitioned into a grid of square cells. You are given an m into an integer matrix heights, where heights of r comma c represents the height above the sea level of the cell at the coordinate r comma c. Okay, so let's see what this is. So this is the island, and this island is partitioned into cells. Okay, so the cells are numbered 1, 2, 2, 3, 5. So what exactly are these numbers? Okay, so these numbers are the height of that specific cell above the sea level. Okay, so let's suppose the sea level is 0. So this 0 comma 0 is situated at a height of 1 unit above the sea level. This cell is situated at a height of 2 units above the sea level. In the same way, this cell is situated at a height of 7 units above the sea level. Okay, so in this way, this island is partitioned into a grid of cells. Okay, the island receives a lot of rain, and the rainwater can flow to neighboring cells directly, north, south, east, and west, if the neighboring cell's height is less than or equal to the current cell's height. Okay, so let's take one cell here. This is this cell's height is 2. So when it rains on this cell, the water can flow from this cell to any other cell whose height is less than or equal to the current cell's height. Okay, so this is 2. Uh, there is a cell which is which whose height is 1. Okay, the water can flow from here to here. The water can flow from here to here as well, because less than or equal to the current cell's height, the water can flow from here to here as well. Uh, yeah, in this case, the water cannot flow from this cell to its above cell, because the height is not less than or equal. Here, the height is greater than the current cell's height, so it cannot flow. Okay, yeah. Uh, Water can flow from any cell adjacent to an ocean in, into the ocean. Okay. So from from any cell adjacent to the ocean, the water can flow from the cell to the ocean. Okay. So the water can flow from this cell to the ocean, 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 this cell to the ocean. Any of these 5 plus 5, 10, 16 cells, it can flow. Okay. Any of the border cells. These are known as the border cells. From any of the border cells, it can flow to directly into the ocean. Okay. Return a of 2D list of grid coordinates result, where the result denotes that rainwater can flow from that cell to both the Pacific and Atlantic Oceans. Okay. So here the question is, from which cells the water can flow from not only to flow to not only to one ocean, it can flow to both the oceans. Okay. Uh, let's see this example. Here the solutions are 0, comma 4. 0, comma 4 is this cell. From this cell, the water can flow directly into Pacific Ocean, and it can flow directly into Atlantic Ocean. Okay. So this cell constitutes water to both the oceans. So this is one of the answer. Next, 1 comma 3. Let's see how 1 comma 3. With 1 comma 3 is this cell. From this cell, it can water can flow from here to here, and then here to Atlantic Ocean. Okay. From this cell, water can flow from here to here, and this cell to Pacific Ocean. Yeah. Next, 1 comma 4. What is 1 comma 4? This cell. From this cell, water can flow water can flow directly to Atlantic Ocean, or water can flow from here to here, and then to Pacific Ocean. Great. 2 comma 2. Where is 2 comma 2? 2 comma 2 is this cell. From this cell, water can flow from 5 to 3, 3 to 1, and directly to Atlantic Ocean. 5 to 3, 3 to 2, and directly to Pacific Ocean. Nice. 3 comma 0. Where is 3 comma 0? This is 3 comma 0. It can flow directly to Pacific Ocean, or it can flow from 6 comma 5 and 5 to Atlantic Ocean. 3 comma 1. This is 3 comma 1. From 3 comma 1, 7 to 6, 6 to Pacific Ocean. 7 to 1, 1 to Atlantic Ocean. Great. 4 comma 0. 4 comma 0 is this. It can flow directly to Pacific Ocean. It can flow directly to Atlantic Ocean. Okay. So our task is to find the cells, the coordinates of the cells, uh, whose water can flow from the cell to both the Atlantic Ocean and the Pacific Ocean, not one, to both. Okay. So how can we write the solution? Uh, we can write the solution by using BFS. Uh, i- See, in the question we were doing like from each cell we were going outwards and finding a path to both the oceans. Instead, what we can do is we can consider the border cells, and from all the border cells, how many cells we can go inward? That will be our answer, right? So from 5. From 5 we can go to this cell and as well as to this cell. So they are the answers. So in the same way, for each border cell, we need to find out how many cells can be visited from that border cell. So the ocean water can flow from there to the ocean. The rainwater can flow from there to the ocean. Yeah. So this will be our approach. For this, we need to do the breadth first search, and instead of checking for the height less than, we need to check for the height greater than. From while going outwards, we were checking if there is a slope, but as we are reversing our approach, as going inwards, we need to check if the height is greater than, if there is a steep. Okay, so let's start coding. Okay, yeah. How do we code this? Uh, First, let's uh, see the height. Heights dot length. If what are the constraints? Okay, heights of r comma c. Okay, and int columns equals to heights of 0 dot length. Okay, great. And what else we do? Uh, we should have a visited matrix for both the Atlantic Ocean and the Pacific Ocean. Okay, so Boolean. Let's name it visited Atlantic equals to new Boolean of rows comma calls. Okay, and for Pacific Ocean, we need this matrix. Okay, great. And what else we have to do next? Uh, we need to have a queue. Uh, Queue of integer array. Let's name it Atlantic queue equals to new array list. Okay. And next, queue of integer array, Pacific queue, new array list. Uh, we can take linked list actually. Yeah. Great. Okay. Next, the next step is we need to mark the visited cells. Okay. What all cells can be visited? These border cells can be visited. Okay. So for int r equals to 0, r less than rows r plus plus. Every top and the left cell can be visited by Pacific Ocean. Okay. So let's add them into Pacific queue. Pacific queue dot add new int for every row uh, r comma 0th cell, and for every Atlantic row, for every row, the last cell. Okay, great. And let's mark them as visited. So visited Pacific of r comma 0 is true. Visited Atlantic of r comma cols minus 1 will become true. Great. In the same way, we need to do for the columns as well. For int c equals to 0, c less than equals c plus plus. Yeah, Pacific q dot add mm, new int of with respect to columns, for every column the first cell. So for every column the row will be 0 and the column will be c. Great. And Atlantic q dot add unit of for every column the row will be rows minus 1, the column will be c. Great. And let's mark them as visited Pacific of 0 comma c equals to true, and visited Atlantic of rows minus 1 comma c is true. Yeah. So next, what do we do? Next, we need to perform the BFS algorithm on both these. So let's pass the heights array. Next, let's pass the Pacific queue, and that let's pass the visited of Pacific. Okay. Next, we need to do BFS for the Atlantic as well. Heights. Let's pass the Atlantic queue, visited of Atlantic. Great. So we should have a result as a list of integer. Okay. List of integer result equals to new array list. Okay, and for int r equals to 0, r less than rows r plus plus. For int c equals to 0, c less than calls c plus plus. If the condition should be the cell should be in visited for both Atlantic visited array and the Pacific visited array. Okay, so for visited of uh wait a second, visited of Pacific of R and C and visited of Atlantic of both R and C, then we need to in the result we need to add arrays dot as list of R comma C. Great. Then we can return the result. Great. So now it's time to write the BFS function. Great. How do we write the BFS function? Simple. Public void BFS. We need integer 2D array heights. We need a queue of int integer array that is q, and we need a boolean 2D array that is visited. Great. First int rows equals to heights dot length, and int calls equals to heights of 0 dot length. Great. Now what do we do? Now here simply what we can do is uh, we can do the BFS. So while not of q dot is empty. Yeah. Uh, we need an integer array. It is current is q dot poll. This will be our current cell. This is our current cell, and our current row will be the current row uh, is current of 0, and current column is current of 1. Great. Now we need to have a directions array. Uh, directions directions. We can go 0 comma 1, which is going to the right cell. We can go 0 comma minus 1, which is going to the left cell. We can go 1 comma 0, which is going to the bottom cell, which is going to the downward cell. And we can have minus 1 comma 0, which is going to the upward cell. Great. Yeah. So we have got current row and current column. Next, what do we need to do? We need to check in all the possible directions which we have mentioned. So for integer array direction in directions. Int next row will be current row plus direction of 0, and the next column will be current column plus direction of 1. Great. So here we need to check for some conditions like uh, condition boolean. Condition 1 is if the next row is out of bounds. It's like next row is less than 0, or next row is greater than or equal to rows, or next column is less than 0, or next column is greater than or equal to columns. This is the condition 1. Next, condition 2 will be if the cell is visited. If visitor of next row and next column. If it is visitor, okay, great. One second, one second. Yeah, sorry, that was a call. And Boolean condition 3, which is if the height of the neighboring cell is greater than that. So we need to check if the height is less. So height of next row and next column should be less than, uh, should not be less. So it is the condition height of current row, comma, current column. Great. If any of these three conditions passes, then we can continue this iteration. Yeah, and then we can mark the cell as visited. Equals to true. So this will mark this cell as visited, and we can add the cell into the queue. So queue dot add uh, new int of next row, comma, next column. Great. So yeah, this is it for the BFS, and yeah, let's check if we are right. HEIGHT. What? Yo, it should be heights, if I'm right. Yeah. Uh, Here also it should be heights. Great, great, great. Uh, Heights. Okay, let's go. Mm, where is error? Okay, not of condition one because it will check for the condition. Great. Here we'll get the same error and not of condition one. Great. Okay, so the sample test cases have passed, and let's submit. Great. Yeah. So this solution has passed all the test cases. So this is how we solve the Pacific Atlantic water flow problem. Hope you understood this problem. I suggest you to listen this video in 1.5x so that you can understand much faster and much better. Yeah. So please do make sure to like, uh, comment and subscribe to my channel. Uh, thank you. Thank you very much. Yeah. Bye.